Chapter 13, problem number 62. The maximum distance from the Earth to the Sun at our aphelion is 1.521 times 10 to the 11th meters, and the distance of closest approach at perihelion is 1.471 times 10 to the 11th meters. If the Earth's orbital speed at perihelion is 3.027 times 10 to the 4th meters per second, determine A, the Earth's orbital speed at aphelion, B, the kinetic and potential energies of the Earth-Sun system at perihelion, and C, the kinetic and potential energies at aphelion. Is the total energy constant? Ignore the effect of the Moon and other planets. Our given values is the distance at aphelion, 1.521 times 10 to the 11th meters, the distance at perihelion, 1.471 times 10 to the 11th meters, and the speed at perihelion, 3.027 times 10 to the 4th meters per second. We must find A, the speed at aphelion, or velocity. C and B are the same for aphelion and perihelion. We must find the kinetic and potential energies of the Earth-Sun system at both perihelion and aphelion. So, our equations for finding the velocity is m times r times v is equal to m times r times v. M is mass, r is distance, v is velocity. Our next equation is K, or kinetic energy, is equal to 1/2 mv squared. The P is perihelion, but the same equation is used for aphelion. K is kinetic energy, m is mass, and v is velocity. For potential energy, the equation is U is equal to negative, don't forget the negative, G, the gravitational constant, times m, lowercase m being the mass of Earth, or of one body, and in this case Earth, and uppercase M being the mass of another body, in this case the Sun, over R. And again, the sub P is for perihelion, but it is used for both perihelion and aphelion. R is the distance. So, gravitational constant is measured in newtons times meters squared over kilograms squared. That's important for when you are doing your equations. Our constants are the mass of the Earth, 5.98 times 10 to the 24th kilograms, and the mass of the Sun, 1.99 times 10 to the 30th kilograms. For A, the net torque exerted on Earth is 0. Momentum is conserved. So, step 1, all we must do is plug in the values from our initial equation and change the order to solve for velocity. So, velocity is equal to velocity perihelion times distance perihelion over distance aphelion. Solving for those values, 3.027 times 10 to the 4th meters per second times 1.471 over 1.521 gives us 2.93 times 10 to the 4th meters per second. Step 1 for part B is to find the kinetic energy. we will use the same equation as it is at the top with no alterations, and plugging in the values for that give us 1/2 times 5.98 times 10 to the 24th kilograms times 3.027 times 10 to the 4th meters per second squared. The answer, when you plug that into a calculator, is 2.74 times 10 to the 33rd joules. Do not forget, it will be joules because meters per second times kilograms gives us joules. Step 2. Find potential energy. Same thing, plug in the values that are given into our equation for potential energy. So, 6.673 times 10 to the negative 11th, the gravitational constant, times 5.98 times 10 to the 24th kilograms, times 1.99 times 10 to the 30th kilograms, over 1.471 times 10 to the 11th meters. That is the distance. So, our answer for that is negative 5.40 times 10 to the 33rd joules. Remember, it is joules. If you solve for your units, you will derive joules. So, for C, we do the exact same thing as B, using the different values for aphelion and perihelion. So, 2.57 times 10 to the 33rd joules is the answer when you plug all those in. And for potential energy, exact same thing as part B. You can go back in the video if you need to see it again. And the answer for that will be negative 5.22 times 10 to the 33rd joules. Step 3, we need to compare the values as it asked at the end of the question. Is total energy conserved? So K perihelion plus U perihelion, the kinetic energy plus the potential energy, give us negative 2.66 times 10 to the 33rd joules, and K aphelion plus U aphelion gives us negative 2.65 times 10 to the 33rd joules. Therefore, they agree because the values are the same.